Okay, so hello everyone, welcome to the second town hall. As you have noticed, this town hall is also recorded so that we can put the video on the web page. That's just for your knowledge. So the agenda is pretty large. We have a lot of stuff to handle today. First will be the welcome and housekeeping by me, then historical context and meeting goals from Sanjeev, then K2 by Dan, Lhotse by Piotr, then will be panel discussion moderated by Mayu Wang, and then finally audience QA, depending on how many people we will still have those times. So if you have any questions and it's not something that needs immediate clarification, then we ask you to fill out issue at the GitHub page on the links you see here. Also, if you go to kaldi.dev and click on do you want to get involved, you can also see the ways how to get involved. If it's just a clarification question, feel free to ask in the chat, or there is a button that says Q&A, so you can use that one. That's all from me. And now it's Sanjeev with the historical context and meeting goals. Once again, welcome.
As you all know, Kaldi started as a summer project at one of the Johns Hopkins workshops back in 2009, when it was not yet called the Jelinek Memorial Workshops. Jelinek was still alive and well with us. And Dan led a team along with a number of other people. Luckily, many of them are actually in the audience today, Nagendra and Peter Schwartz and so on, who basically started Kaldi as a project, as an open source project to make speech recognition easier for everybody to work with. At that time, SGMMs were the vogue. And then we formally made it an open source project, I think, at the Prague ICASP in 2011. Since then, it has gone on from strength to strength. Once deep learning became a bit more established, we jumped on it. And around 2012 or so, we started putting in DNN components in Kaldi. And today, it is a nice, thriving open source project. This is just a snapshot from the GitHub page. It has more than 300 contributors, several thousand forks. A lot of people follow us closely. And in general, it has been a big help in making speech recognition possible. Of course, this happened in parallel with the whole conversational AI, the revolution that's been happening even otherwise in industry. This just brought a lot more people into the fold, and it has been good. But as Dan said in the meeting last week, when we started these town halls, Kaldi is starting to show its age, and it is time to sort of, think through what's next and make major revisions. So that is why we're here today. So one of the things we want to do, and when I say we, I don't mean just Dan, Yenda, me, the main contributors of Kaldi in the past. I really mean the whole community, all of us together, including students and academic people whom we talked to last week, and you guys who are going to talk to us today from industry. We want to sort of start integrating with deep learning frameworks, PyTorch or TensorFlow, MXNet, whatever you choose. We want to get the automatic differentiation through the FST components going so that we are not hostage to only certain types of end-to-end training. And then, of course, streamlining data so that when you have large data sets, which are not easy to do simple disk-based, single disk file IO with. So these are some of the things on our minds. So the goal of these meetings is essentially to get a sense of what is needed. We got some of it from the academics last week. We'll get some more from you today. Next, we want to get some input from you about how. A lot of you have a lot of experience building, deploying ASR systems or other deep learning systems. So what are the issues that are important? What should we be paying attention to, particularly design decisions? And finally, helping us generate enough enthusiasm in the community that some of you and others help and do the implementation. So that's our goal. We are starting it off with this town hall process. There will be a GitHub page to continue the discussion. There will be discussion on the Kaldi Google group and so on. With that, let me turn it over to Dan. Dan?
Okay, so so the problem is Kaldi is, it's getting old. It just wasn't designed in the way that you would design things now. And some of the decisions are kind of hard to undo at this point. Like if we could go back in time, we'd probably design it all based on Python and integrate with things like PyTorch or TensorFlow, but it's hard to do that. Now, the thing that a lot of people have been asking for is if we just switch the neural net part over to PyTorch or TensorFlow. And I did actually spend a lot of time thinking about that, and with some people here in Beijing, I even like started on towards that goal. We even got a prototype working, but in the end, I started to feel like it wouldn't be worth the effort. And the reason is that, well, firstly, there's a slight mismatch in the design. That Kaldi was designed for a certain type of use pattern. And if you just add PyBind 11 bindings to everything, it starts to feel a little bit like putting lipstick on a pig. The design just doesn't quite work. And it started to feel a little bit like rolling a stone up a hill, that it would never be finished. And that at the end, what we would have wouldn't be clearly better than what we have now. I mean, it would be more flexible, but it wouldn't be a very elegant design. So we're going to be doing a different plan. And the plan is to separate everything into different pieces, where for the neural net stuff, we just use external toolkits. When we separate the kind of modeling stuff from the data preparation stuff. So Lhotse, a totally separate project that Piotr is going to talk about, is all about representing collections of audio data and like augmenting them and dealing with transcripts and things like that. And then K2 is the kind of, contains the non-trivial parts of the things that need to be in C++. I'll explain what it is. And then the actual recipes, we don't know what that'll look like yet, but it will require all of these, something from each of those three buckets. So K2, yeah, named after the mountain. The basic goal is to add a finite state acceptor as an object that you can use in PyTorch and eventually TensorFlow, maybe other toolkits as well. So the idea is that you can do standard finite state acceptor operations, things like composition, determinization, that you can do those on the GPU fast and have it be differentiable. And by differentiable, just in the sense that you can backprop the weights through those operations. It requires you to slightly reformulate some of the operations, but it can be done in general. Now, this was not a feature that a lot of people were asking for, but I do maintain that it's useful. One example is you can cast CTC training and lattice-free MMI training as basically the same FSA operation. So that instead of having to use special purpose code for those things, you can use a single piece of code. So basically both those operations are just pruned composition. What can be done as pruned composition plus computing and expectation. So one of those two FSAs has a regular structure. It's just a neural net output matrix. So this is what the code would look like if you were to do this, if you were to write a Python script as part of your training. It would, what I've written here is actually extremely close to the way it's going to look in practice. I mean, some of those function calls might have a couple extra arguments, but those are things that it's not exactly working yet, but I know almost all the details of how it's going to work. Now, so the K2 project is mostly C++ and CUDA code, but it's intended to be used mostly from Python. The main data structure is quite similar to TensorFlow's ragged tensor, which is not something most of you will have heard of. it's similar to just a list of lists, but the lists have to be of a certain depth, the same depth. But it's intended for use on the GPU. It's efficient for use on the GPU. It basically allows you to implement fairly arbitrary algorithms on the GPU. I mean, you can't actually do that in TensorFlow very easily because TensorFlow is based on composing individual operations. The way K2's code works is a little bit different. It's more based on evaluating lambdas, where the lambda is kind of executed in parallel for all of the elements of one of those lists. It's hard to describe without giving more details than you want to know right now. So at the C++ level, there's not much mention of autograd. The autograd is down at the PyTorch level. And basically all we need to do in C++ is for each output arc, we need to keep track of which input arcs it corresponded to. So the purpose of this slide is to show you that you'll be able to do some interesting things in K2 that would not have been possible before, or at least would not have been easily practical. The idea here is that we'll estimate confidence. When we first, this is the first of some code. I haven't put the rest of it. But what it's basically starting to do is create lattices by this pruned composition, accumulate the reference through the same thing using the supervision. And then it starts to compute a bunch of features that it'll basically append together and associate with those lattices. And all of these K2 FSA objects, they have this kind of pseudo field or whatever per arc, where basically you can assign any tensor to there as long as it's the same dimension as the number of arcs. And basically it's like adding named quantities that will be inherited when you do further operations. So if you add some features to the lattices that way, and then let's say you take the best path, those features will be propagated to the best path. Anyway, there's like another page of this, but I'm not showing that. So we're hoping for this to be released mid to late October. I mean, I guess late October is getting more likely now, but we should have something by then. The initial version probably won't have anything very interesting going on because we won't have implemented all the operations yet. It'll probably just have CTC and lattice-free MMI, but the point is that it's a stepping stone to a lot more flexibility. How long did you lose me for?
Oh, not much. We were okay.
Okay, good. All I was really saying is that we're aiming for like a mid to late October release. And I think I can finish up with that.
So my name is Piotr. I joined JHU recently and started working with Najim, Sanjeev, and Dan. And now I will show you the other library that Dan mentioned, Lhotse, which is supposed to make audio data preparation simple and kind of universal. That's what we hope to achieve here. So just to give you, I will just give you very short teasers, like try to give you an overview. If you're interested, there are links, you can go and check it in detail. So first of all, Lhotse is Python centric. Like right now, practically everything is implemented in Python, which probably makes it easier for many people to use and extend. The main concept is that we separate the corpora and the data sets. By data set, I mean a data structure like PyTorch data set that prepares your data for a very specific task, like speech recognition, voice activity detection, etc. So it should be easy to combine multiple corpora to perform the same task, or use one corpus to perform multiple tasks on it. Multitask training could be one of the use cases here. And finally, there's a notion of audio cuts and supervisions that makes this data preparation simpler. So what are these cuts? Cuts are just a cut, like a segment of the recording, which has some kind of defined supervision. The supervision does not have to cover the whole cut. And it enables you to do many things with this chunk of audio. Like you can truncate it, you can pad it, you can append different chunks of audio together, you can mix the cuts with different signal to noise ratios. You can use that, for example, to pad the signal with something else than silence, like noise, for example. And of course, you can compute the features. You can compute them on the fly, or you can store them somewhere and load them later. There's also support for data augmentation. And the nice thing is that all of these features, all of these operations are composable and lazily executed. So this is kind of a preparation for us to work with larger data sets and maybe something that is not necessarily entirely on the file system. Maybe you need to download data from S3 or something, and that will work. So how the data is structured, there are basically three kinds of manifests. One we call the recording set, which describes the whole recordings. Now, these may be short segments. There may be 5 hours long recordings, and this is just some basic metadata about them. There's the supervision set, which describes the actual speech segments and some other metadata along with that, like the speaker, language, gender, etc. And these two are specific to a particular corpus, and then you combine them into a cut set. And the cut set kind of holds all the relevant information together. So you can actually do a lot of things with that. And the cut set is the common representation that is consumed by these dataset classes. So the dataset classes actually work out from the cut set, okay, should I give you the features? Should I give you the audio, the transcription, whatever you might need? So one last example, how you can work with long recordings. You can practically cut them in multiple ways. I showed 2 ways here. One of them, you can cut them directly to the supervisions, like this would work for ASR, for example. Another way, you can cut them in equal segments, equal cuts, and that would work, for example, for speech activity detection or speech diarization or other things. And a very short code example just to convince you that data preparation doesn't have to be hard. You don't need a lot of code for the standard things, like make simple things simple and make difficult things possible. All right, thank you for your attention. That's all from my side.
Hi, everyone. Welcome to today's discussion. Today we will be focusing more on industry. And we will start from introduction of all of our panelists. And everybody has 1 minute to talk about yourself. And to illustrate how big impact Kaldi is, when you guys introduce yourself, please identify where you are physically. Now that everything is virtual, we are everywhere in the world. And Gogo, would you like to start first? I'm following Sanjeev's list.
Sure. Thank you very much, Mei, and glad to be here. So I'm virtually here in Seattle for now. And so for me, I did my PhD from CSP, so spent many years with Yanda, then Sanjeev. Also did a lot of code work for Kaldi during my PhD. After graduation, I started a company called Kid.ai. And we were mostly focusing on this developer community for speech and NLP technologies. We had over 100,000 developers at that point, and we were acquired by Baidu in 2017. After the acquisition, I served as the principal architect for Baidu's smart speaker business. And we shipped over 19 million smart speaker devices in 2019, and we handled over 5 billion voice queries in December alone. Early this year, I left Baidu and started 2 new companies called Seesaw.ai and Wubu.com. We are focusing on the contact center and the QSR business, respectively. For all those companies, Kaldi is heavily used, And since now I'm more flexible, so I would like to contribute more back to the community, and that's it.
Ivan, next.
Hello, everyone. I'm Ivan Medenikov. I'm physically in St. Petersburg, Russia. I'm working in STC Innovations company. We make ASR for Russian language and other languages as well. And we actively use Kaldi for acoustic models training, but we have our own code for production because of stability and speed. And also we have other teams in STC, for example, voice biometrics team, and they also use Kaldi for their experiment. Okay, I think that's all.
Thank you. Next one, Jun Suk, if my pronunciation is okay.
Yeah, that's correct pronunciation. Thank you for introducing. My name is Jong-Suk Kim. I'm principal machine learning scientist at the Twilio. I started using Kaldi since I started working with Ian at the Carnegie Mellon University as a research purposes, and then started a company called Capio.ai. And we used the Kaldi for the training and also the engine with the modification of the code. Since then, we are acquired by the Twilio 2019, and we are actively working on the customer engagement platform using the speech recognition, how we can evolve the using the speech recognition technology to analyze and provide a better metrics to the customer call center applications. We are also actively using Kaldi for the training as well as the engine. As Kaldi is a great starting point, it gives lots of help, but we had to make lots of modification to stabilize the platform and to make an industrial standard, make the code to be deployable in the industry productions. And I hope, I'm really happy to join this town hall meeting as a panelist, and I hope I can help to improve the K2 for industrial application as well.
Thank you. Next panel is Karel. I'm not sure what is the right pronunciation.
Karel Vesely.
Yes, it is. Yeah. So hi, I'm Karel. I call from Brno, Czech Republic, and I work on like two things now. One is at the faculty that we have a project with air traffic control. So we do like the transcription of the tower and pilot communication. And the second work is Soapbox Labs, which is in Dublin. And there we do child speech. So we do stuff like evaluation of the pronunciation. We have collected quite a lot of data of children recordings. Right now, I think we have 4 languages. So not just English. And we also started looking into the fluency of the early literacy, that so we like measure how well children can read. I joined Kaldi pretty much not at the very beginning, but the second year maybe, during the first workshop, which was in Brno, and I was programming the first neural network implementation, the NNet1, which now it's a bit obsolete code. There was also this tiny CUDA library, which later evolved dramatically. So, and then I, over time, sort of pulled back from the project. So I'm not that much active now anymore. That's all from me.
Thank you. Next person, Kirill.
Yeah, Kirill.
Kirill, thank you.
Or is he here?
I don't
Sure.
see Cyril at the moment.
He's not?
Okay. Okay.
Yeah, let's move on to the next one. Mark.
Hello, everyone. I'm physically in Stuttgart in Germany. I work for Sony as a principal scientist. And well, thank you for inviting me to this panel. We've been using Kaldi, well, I've been using Kaldi for quite a long time before, when I was at DBF as a postdoc, and and so on. But now at Sony, we use Kaldi, and we've been using Kaldi for quite a long time, basically for research purposes, and especially to keep up with state-of-the-art modeling, which has been quite difficult in the last years, right? That's essentially why we're here, and probably why we're discussing all of this, right? So yeah, Kaldi is extendable. Kaldi, we've been doing that, but it's extremely time-consuming and many times not worth it, especially if you do some research on it. It might be not worth the effort. So I think probably many people here from other companies have already thought of making this move out of Kaldi. We know that some companies have done it already, and I'm glad that the Kaldi original developers are involved in this move, right? Yeah, so that's all.
Thank you. I'm Mei Huang. I have been in speech field for a long time, more than 2 decades, and I was one of the main contributors for Sphinx 2. After my PhD, I've been working at Microsoft on and off for about 18 years. In between, I worked at University of Washington, and eventually I landed at a startup company called Mavoy. And Mike Lay, who is the CTO, is in the panel as well. So I will let him introduce Mavoy. And that's when I get in contact with Kaldi, enjoy doing all the work. And due to the pandemic, I cannot travel to China anymore. So I just returned to Microsoft recently, working on NLP, language understanding related stuff. All right. Next person, Miguel.
Yeah,
This
thank
is
you.
my later to sound.
I'm Miguel Jete. I'm calling from BC, Canada. My background is contrary to everybody, I think, in evolutionary biology. But I started to work at Nuance maybe 15 years ago. And recently moved about 4 years ago to a company called Rev.com. Rev.com does human transcription. It's a human transcription marketplace. And we started training our own models and offering them on RevAI as an API, but also using them internally in ways to, try to make humans a bit more productive. We definitely use Kaldi a lot for training and inference. And I think like everybody else has said, we've tweaked Kaldi quite a bit, but we're very excited to see this new development and be part of it.
Thank you. Next person, Mike.
Mike, you may be muted.
Oh, it's me? Okay.
Yep, good.
Sorry. Okay, so let me first introduce Mavoy a little bit. Mavoy was founded in 2012. One of the main co-founders is Jifei Li and also Sanjeev's PhD student. And we are focusing on Chinese voice interaction technologies. We have been funded by Sequoia, Google, and the Volkswagen Group China. So we started with Kaldi, the DNA recipe, and in 2013 we were able to launch the production service. The first production service was already in DNN and skipping the GMM part. Our main speech products currently are wearable products like smartwatches and automobile products like the voice assistant for the Volkswagen cars. Currently, we provide the default voice assistant for Google Wear OS smartwatches in China and lots of Volkswagen new cars in China. So we're happy that lots of code of Kaldi have been used in Volkswagen cars in China. Thank you.
You didn't mention, but one of your employees is working on K2 as well. He's actually contributed a lot of code, Fangjun Quang.
Yeah. We were able to help Dan in the early, PyTorch vacation of Kaldi earlier this year.
Yeah, but he's still working on K2. He told you that a few days ago. Yeah.
Yes.
You're making a lot of progress on that. No, thanks.
Okay, cool. No problem.
Yeah, Marvel is based in Beijing mainly, but both Mike and I are currently physically in Seattle. The next person, I guess we have to hurry up. Mohammed.
Hi, nice to meet you all. I co-founded a company, speech startup called Voicea that got acquired by Cisco. And I currently work at Cisco as director of AI for contact center solutions. And I also teach as teaching assistant some sections at Stanford. We do machine learning and deep learning, and I help students there for these classes with their speech projects, namely, and also startups. I advise some startups on speech. So I'm very excited for the change because it's been really something we have been looking forward to, and I think it addressed a lot of the challenges we've been facing.
Thank you. Next person, Nagendra.
Yeah, hi, I'm physically in Northern Virginia, about 1 hour south of Johns Hopkins University. I am also the first graduate student from the Johns Hopkins Center for Language and Speech Processing. I started using Kaldi practically while we were working on it because at that time I was also starting up Go Vivace, which is 11 years old now. At Go Vivace, we essentially started off with speech to text transcription projects, but later on evolved into doing voice biometrics, language ID, emotion detection, and for the transcription systems we use both for call analytics, transcription, and also for conversational AI platforms. So that's kind of the nutshell of what we do at Go Vivace. We use Kaldi quite heavily, and I think pretty much like all the different recipes which exist probably have been explored and used in some ways for certain specific tasks.
Thank you. Next person, Nikolai.
Hello, colleagues. I'm Nikolai from Moscow, Russia. Happy to see you all, my friends.
Happy to see you, Nikolai.
That was quick. Any next person, Peter? I don't know how to pronounce this.
Hi, my name is Petr Schwarz. I am in Brno, Czech Republic now. I studied at Brno University of Technology. I had the chance to join the first Kaldi or JHU workshop and to help a little bit. After that, I based company called Phonexia that is delivering speech technologies to other companies for contact centers, for conversational assistants, is doing also voice biometry. And we are using Kaldi for training heavily. Thank you.
Thank you. Raphael?
Yeah, Raphael?
Raphael, thank you. Is he here?
He was here.
Me?
Yes.
Okay, sorry.
Sorry for
Talking
my
to the void here. Yeah, so I'm Raphael Cohen from Chorus AI. We've been founded in 2015, and we're a conversational AI company. We record Zoom conversations like this one and help people get better at conversations. We use Kaldi heavily from the get-go for ASR and then diarization. I'm still new to this community after 5 years. I come from the area of NLP because we also, most of our work is actually after the ASR is done to get more out of the text and understand the interactions of people. And Kaldi has been great for us. With the help of Nikolai and Dan, we were able to create competitive ASR for our system and diarization. And we've been relying heavily on the recipes to stay on the cutting edge of the technology. We are looking forward to seeing Kaldi remain competitive, as it's very important for us.
Thank you. And you are located?
I'm located in Israel.
Very widespread of the audience. Next person, Romain. Is Romain here? Or is my pronunciation too bad? Okay, next one, Tao. Tao? Yeah.
I'm Tao Ma from Mountain View, California. I'm currently the VP of Language Technology at ASAP, where I manage the research and development of speech, NLP, and machine learning. ASAP is an enterprise AI company. Our product augment contact center agent and automate their workflows. A decade ago, I was a maintainer for open source ASIP decoder for a few years during my PhD. After graduation, I spent my entire career in the industry and I used Kaldi a lot, working on speech modeling, decoder optimization, the large-scale speech services. In the past, I worked on the Apple Series speech team and GD.com. It's my pleasure today to join the panel discussion.
Thank you. Simos?
Yeah, hi everyone. Hi from Athens, actually, Greece. I'm currently head of machine learning and voice biometrics at a company called Omilia, which is specialized in conversational AI and offers services such as ASR, spoken language understanding for dialogue systems, voice biometrics, fraud detection. Prior to that, I was for several years working with Patrick Kenny in Canada, Montreal, primarily on voice biometrics. And then I did another postdoc on audiovisual speech recognition. In Omilia, certainly Kaldi is part of our solution, and we're expecting to see a lot more with this new K2, especially in the interaction between ASR and natural language understanding. Thank you.
Thanks. Wang Kyung.
Hi, everyone. My name is Wang Kyung Lee, and I'm physically in Los Angeles, and I'm working for GridSpace. I have been using Kaldi since 2012 while doing some research at Carnegie Mellon University. In GridSpace, we are building products that help call center, which process live calls to capture valuable data and provide customer support metrics and automate call center. That's why we heavily use Kaldi because the Kaldi shows very impressive real-time performance, especially with GP-online decoder. I want to see if next generation Kaldi K2 can still support a real-time performance. Also, I'm interested in learning how efficiently we can train model with huge data set with next generation Kaldi. Thank you.
Thank you. Javier?
Hey, so good day, everybody. My name is Xavier Anguera. I'm calling from Lisbon in Portugal, south of Europe. So most of you might know me by my PhD work on diarization. Maybe you've used my toolkit Beamformit for acoustic beamforming, which is integrated with Kaldi, and lots of people use it for on their benchmarks. So yeah, I was at ICSI in Berkeley. Then I was working a few years in Barcelona in Telco, Telefonica as a speech scientist. That's where I started using Kaldi, thanks to Carol Vesely that came for a week to help us set up when we didn't know anything about what Kaldi was. And then after a while, I moved from a big corporation into startup. I created my own startup, and finally ended up as a co-founder and CTO of Elsa. So that's where we are now. Elsa is a speech assistant. We help people improve their pronunciation when speaking English. It's an app, we've been running it since 2015. It's been downloaded over 10 million times. And it's all running in Kaldi, both development, research, and also production. So this news for new Kaldi, much more speedy, much better, is great news for me. And also a little bit concerning whether the old Kaldi will just be left aside and let die on the trenches. So I'm interested to hear more, and thanks for inviting me.
Thanks. Last one, Isha. Isha?
It's Isha, but that's fine. Nobody can really pronounce my name, so that's
Isha.
Isha, yes. How's it going, guys? So I'm currently based in Israel for the last 7 months. I was based in Seattle until COVID hit Seattle, then I went back to Israel. I'm started using Kaldi since 2013, and I've been working closely with a lot of the JHU teams, with Dana Hainan, with David Snyder, with Dan. I'm honored to say that I've also worked with Piotr, and before Piotr was joining JHU, we were working together. I found a few companies. The last one, which is Intelligent Wire, was sold to Avaya 2 years ago, and now I'm part of Avaya. The things that we're doing are like analyzing real-time call center agent customer conversations in real time and finding insights, like a lot of people are doing over here. In terms of contribution to Kaldi, we were like the major like early adopters of online decoders back in 2014. NX3, which was published in September 2016, we started using it in early 2016. The team and I with Hainan, we are working on the TensorFlow Kaldi integration, and I'm really excited to see what K2 is going to introduce next. Thank you.
Okay, thank you, everyone. So we among the panelists, we have so many discussions in the last few days, and I tried to cover everything here with this 5-6 different topics, and there are people signed up. I think we are running a little bit late. Let's just dive in, and I would ask each subgroup of panelists, you guys just freestyle one talking after another. I don't want to assign people to talk. So the first topic is about runtime inference. Maybe Mike, you can start, and then the other panelists can jump in.
Okay, sure. So I can see this subgroup attracts the most amount of people, partly because the runtime is way more important for our industry folks than academia. So model training is very important to achieve the best accuracy results. But what matters most to industry people is definitely the best trade-off between accuracy and runtime performance. As industry people, we have lots of constraints, either on the server side server costs, or on the device side, we have CPU memory consumption requirements. And how to achieve the best performance in terms of accuracy, real-time factor, and latency in streaming ASR tasks are very important to industry people. So for K2, I think still there are 3 aspects that we need to focus to get the best mileage for the industry people. The first one is efficiency. So we want to continue the good Kaldi tradition, which has reasonably efficient runtime C++ code, and hopefully can be better integrated with MKO for server side, or TF-Lite for or other runtime inference engines for the embedded side. So the second aspect is embedded. So the bigger companies have been providing server-side APIs. So I think for smaller startups, more and more opportunities will appear in the embedded side. So the on-device runtime support for especially the ARM platform and how to make it efficient to, for example, quantization, specification, teacher-student learning, etc., to achieve good performance, small footprint, low power systems is very important. The third aspect is the technology completeness. We want to have full stack speech technology runtime support needed for real life speech interaction task. So it's beyond ASR. We need components such as VAD, endpointer, confidence, ITM modules, and also for interaction cases, we have weak word and possibly speaker ID, etc. So that's my wish list for the K2.
So the fact that the actual neural net stuff is going to be done in PyTorch and TensorFlow should make it easier to take advantage of existing capabilities they have. And also like things like Onyx. The question will be which parts of K2 itself will run on various hardware. And that will require some coding.
Yeah.
Hopefully not a vast amount. Like it should be relatively easy to make that code work on like different architectures and multi-core and stuff.
Yeah.
You know,
so
but relatively easy is relative.
Yeah. So we do have to support all the platforms, but several of the major platforms such as the ARM and the major CPUs.
Well, ARM shouldn't be a problem because it's just standard C++.
Before we move on to the next topic, I want to have a second person to chime in on this topic.
Yeah, I think Mike gave a very good coverage of what needs to be, what are the challenges. One thing I do want to add is, Onyx somehow is not compatible with for example, I think there is an issue doing the transformer style architecture, porting that to Onyx and TensorFlow at the moment. So like Torch Vision is not fully functional for all the different architectures. So it might be a good idea if there is somebody in the community who is looking into those kinds of issues and making sure that the architectures that we are using are actually supported through these kind of intermediate platforms and eventually support the inference on a C++ style code base.
Cool.
One question to Dan that regarding the K2 decoder, how easily we can support the on-the-fly language model biasing? I think that's one of the big strengths for Kaldi.
Okay, so I mean, it shouldn't be too hard to write a wrapper that will wrap some external FST or FSA type code that supports that. Now, I'm planning to mostly rely on context-independent phones for this new toolkit. You just rely on the neural network to take care of the context. So these things should become less complex than they used to be.
Okay.
I think eventually I'd like to implement it all in K2 so there's no like big extra dependencies, but it should be very general purpose.
General purpose, that's, and I think in your plan about the K2 design, you mentioned like decoding is just a prone composition for FSA, right? And then it implemented the FSA operation. It can be implemented in a GPU-friendly way. Does that mean that the K2 decoder can easily leverage GPU? Do we get GPU decoder like for free?
Yeah, actually, this basically the same code would be running in training and decoding.
Right. From industrial user perspective, that is a huge advantage, right? Because the GPU has a big advantage on the cost per flops, right? Right now, for Kaldi decoder, it's a little bit tricky to implement in the right way. People try that, but if the K2 decoder natively supports GPU decoder, that can be a big performance win, right? Regarding the RTF, like maybe 10 times better than the Kaldi decoder. I think we are pretty excited after we look into the plan of the K2 development regarding the performance of the K2 decoder.
I think that, I'm sorry, Mark.
Yeah, I wanted to ask you whether these K2 decoder and all of these algorithms that you've thought, like rethought to work, thinking of CUDA parallelization, will work straight away on CPU as well, or there are no loops you said and things. Yeah, go ahead.
Everything will work on CPU. It'll just be slower.
It's slower than GPU, or slower than a regular C++ decoder.
Okay, let me think about this. Well, it won't be as optimized as the regular C++ decoder for CPU because the data structures will have been optimized for GPU, but it would be easier to parallelize to multi-core.
Okay, multi-core CPUs. And regarding the Kaldi decoders, will there be, well, Kaldi decoders you can always use a map decoder, but would there be an easy interface from K2 to the old Kaldi decoders if we ever want to use them?
Well, what we might do is create projects where we use both of them. And I mean, I'd rather keep K2 itself clean of like dependencies that are big like Kaldi. But I definitely plan to make it easy to use Kaldi decoders where
to interface with it.
Yeah.
Okay, thanks.
There are lots of data processing, and then that's K2 separated, and there's a Python binding. So where we have for K2 decoder, where we have like a pure C++ implementation for the decoding of the the whole thing, feature extraction, everything.
Well, I mean, so K2 won't do like things like feature extraction. That would be done probably in Lhotse. As for the, I'm sorry, I lost. What were you saying before about the feature extraction? Before the feature extraction?
Like if for example, if the feature extraction is by Lhotse, and Lhotse there's Python only, right? If we want to do a pure C++ decoder using K2, does that mean we should maybe use a Kaldi feature extraction?
Yeah, well, we'd have to write a little bit of code for that. But it wouldn't be too hard to extract pieces. Like we haven't really, right now I'm focusing on just getting K2 to work. We can later on think about things like
because I think industrial user prefer C++ a lot due to the large scale speed services. If we can have a reference, not like some community, some other contributor, like people, when we have that available, a reference, the whole C++ available as an online decoder, I think people will be quite appreciate that, in my opinion.
I mean, so the only slight complication is that I'm envisioning doing things with K2 that aren't standard, do the neural net and then decode, you know, things like where there's multi-pass and RNN-LM and maybe confidence estimation on the lattice. And those are the kinds of things that it's a bit like PyTorch where you define the algorithm in Python. So then to actually port that to work in C++ only, you'd have to reproduce that algorithm inside C++ code. Or I mean, maybe there's smarter ways to do it, but it's not trivial because something like Onyx won't know about K2, right? So you can't just export the graph. So we might have to leave that I mean, we'll keep it in mind, but we might have to leave it for a few months while we get the basic stuff working.
All right, I have to keep moving on. Now, next topic, this will naturally move to the next one, growing pain. How do we migrate from Kaldi to K2? And I'd like to give other panelists a chance to jump in.
So maybe I'll start. This is Ishai.
Go ahead.
Okay, maybe?
Yeah.
So I took some notes. So I think that, you know, one of the things, and I'm talking based on that we currently have a Kaldi-based system, is what I call the risk versus reward. So we currently have a production level system. It's running really great, super optimized. Everything is doing well. We have our pros and cons with language model adaptation, but when we are thinking about moving into the next step, into K2, so two risks, there is, first of all, the problem of what I call the 10x factor. If we want, to change our system, it's going to be a non-trivial investment, supposedly non-trivial investment. And the question is that, how do we assure that, if we are doing this investment, this non-trivial investment, we are getting much, much better performance or much, much better values from the current Kaldi system, and putting aside that, of course, it's Python and development skill. And I'm just, raising another issue that if you're thinking about new companies, when, for example, I'm putting my CTO hat, so one of the problems is that also Kaldi has already proven itself. So if, for example, I'm a new CTO and I need to explore new speech recognition technologies, the question is whether I explore K2, which hasn't proven itself right now. So maybe we need, to show some use cases or toy models to make sure people feel more comfortable. On the other hand, Kaldi, we know that Kaldi is, using all over the place. So it's, the decision might. So I think that, we should also think about that. And I think that the last thing is that, in US English, it might be challenging because all of the systems are already working, and a lot of the companies already have systems in US English, but it might worth exploring, focusing K2 on other languages, where over there the space is still open and there is a lot of room for improvements, and that might be the entry point to show the good value of K2.
I'm hoping to make it very easy to do graphemic systems, and that should be useful for some of these non-English languages.
Yeah,
well
I think if we could take components from K2 and make it easy to pull those components into the Kaldi code base and use those with the existing Kaldi code base, like replacing one component at a time, that might create a pathway for people to do incremental, like what you are saying about the lattice confidences and all that.
Yeah.
Obviously, that's not happening. But hey, it could be that I don't do that entire change in one shot. Somebody might be working on that code for a few months. But if I have to take the neural network model and just get the posteriors, I can still take the K2 model, plug it into my Kaldi code base and get something. So my training is going on in K2. I'm still inferring in Kaldi code base until I am ready to make that transition and pull in one more piece or something like that.
I'll think about that, but part of the benefit of K2 is just having everything stripped down with few requirements, and like I think I'd rather take bits out of Kaldi and use them inside a more modern project rather than have such a huge dependency.
Mm-hmm. Mm-hmm.
Like the decoder maybe.
Yeah, but maybe if there is this standard, this ONNX format for the neural network, there might be already some library for the forward pass, which could be integrated into Kaldi. And then the question is how to set up the decoder in the old Kaldi so it can process the output of the K2
that should
model.
definitely be possible. I mean,
it could be. Yeah, I'm not saying it will be easy, but it might be like not.
Most of the work would be in setting up the recipes.
It will just make it easy for early adopters to transition while still not transitioning.
Yeah, I see what you mean. Okay. Let me keep that in mind as we develop K2. Yeah.
So is there a plan to? Is there a plan to have sort of a transition time, like in Ubuntu, in Linux distribution, where there is some developer still maintaining, or yourself, Dan, still maintaining Kaldi for a while, being on top of it, or you plan to just leave it on?
Give up maintaining Kaldi. It's more about not spending so much time implementing new features.
Yeah, I second totally my colleagues, my friends here, because really for us it would be a huge change and you really need to weigh in what the benefit versus the risks in there.
You know, a lot of the new stuff I'm planning to do in K2 is about estimating confidences and things like probability of correct phone and stuff like that. And I would have thought that that stuff would actually be quite useful for your application.
True.
How about
very different
confidence would definitely be great.
Regarding the potential of the K2, what do you think the accuracy K2 will be like a similar level with the Kaldi, or potentially could be even more accurate?
Well, I mean, I'm hoping to be at least similar quite soon, like maybe the end of the year, and then hopefully more accurate before long, especially because it should be easier to do things like large scale pre-training and, you know, reusing the model, and just a lot of tricks that weren't so easy to do in Kaldi. Plus all things like RNN-LLM rescoring. So one of the nice things about the system, I hope, will be that it will be a single unified system where you can train your RNN-LLM and just have the inference run very efficiently in something like PyTorch.
Is there any like a suggested way of like move on from Kaldi to K2, for example, like make a K2 decoder or the engine supporting the like Kaldi train the model and gradually moving the training pipeline to K2 as well? So it's okay to be limited on the engine like a functionality, or at least from industry perspective.
K2 is very general purpose. Like it does generic stuff on FSAs and FSTs. So there's no reason why you couldn't cast the regular Kaldi decoder as an instance of that and just use it for like batched Viterbi search.
So probably starting from like porting the K2 decoder, but using the K1 trained model, and then gradually moving training pipeline to the K2 would be the suggested way of onboarding.
I don't know that that's like the first use case that I want to do with K2, because I want to start off with simple things like CTC and Lhotse stream MI in PyTorch, and just have some simple recipes, and then later on think about cross toolkit things.
Yeah. But that very helpful, just some guideline for the industry, so how we can transitioning from original Kaldi to the K2 instead of like replacing everything. That would be helpful.
Yeah, I see what you mean. Well, let me bear it in mind, but you know, sometimes when you combine two problems like that, you make a third problem that's even harder.
Yeah, I understand that.
There's a question about model conversion that many of us were asking.
Asking what?
Model compatibility between Kaldi and K2.
I don't really think there's going to be compatibility, because the whole point of K2 is to be compatible with standard models like PyTorch and TensorFlow, and that makes it a little bit tricky to be totally compatible with Kaldi models. But part of the idea here is that by kind of abandoning the goal of direct compatibility, we get to revisit a lot of decisions that were made a long time ago and fix a lot of mistakes, and not have to worry about introducing 100 options so that you can be compatible with Kaldi.
Is it possible to have a tool to convert?
Yeah. Let me think about that.
So Dan, I was thinking that some of the work that Yiming is doing, like, you know, he's been able to get TDNF models and I think maybe even LSTMs to Kaldi trained Kaldi architecture models to go to, like, you know, through Mace to go to Onyx.
Yeah.
So that
I mean, I guess that is good. And like, I mean, I'm totally for people putting Kaldi models into Onyx and using them in other frameworks, but like, it's the kind of, you know, it's just not the kind of coding that I want to do right now personally. Like, it just, maybe we can get someone else to help with that. I don't know.
No, Dan, so the message I'm hearing, I suppose, is that the current investment in Kaldi models, people want to be able to carry that forward. So to think,
that's what you mean.
Right? Yeah, exactly.
You know, there might be easier ways to do it by, you know, using the alignment or something, or exporting the training data and then just efficiently training a model in the new framework. Like
no, I don't think I mean we can always train models. So I don't think carrying the model forward is the issue. The issue I think is more like, okay, I have this multi-threaded framework already, and I want to transition to K2 quickly, but it's a huge investment to get everything working on day one, and I will not have everything working on day one in K2 framework, which meets all my product requirements. Can I take components from K2 and bring them back to my current programming infrastructure and continue to move along, although I may not have all the advanced features of K2?
Okay.
I'm thinking that it all depends on the benefit, how much benefit of K2 versus Kaldi, right? If the benefit,
because K2 isn't finished yet, I'm not going to try to sell you guys on the benefits of switching. I feel like we have to wait.
Yeah, I mean it's not about benefits. I think the benefits will be there. It's more about how do I make my transition plan and start investing early in it, but not get lost and have an engineering team working for a year and go through a test process and to make something which is equivalent in terms of like the checklist that I have to sign off for the product features compared to what I have today.
Yeah, I still feel it might be a good idea when we start working on the recipes that if we can post some official guideline for switching from Kaldi to K2. I just feel it might make the process easier. You know, for a lot of those startups, we have like variations of Kaldi right in-house, and we made a lot of modifications to the, for example, training a decoder. And as people said, you know, it's a huge investment to move from existing code to the new code like a K2 array. And it might be helpful if we have some official guideline for, you know, switching from the standard Kaldi to K2, and then people can follow the steps and make their own modifications. And in the future, you know, if K2 is like, for example, K2 gives way better word error rate, I think it's a no-brainer for people to switch from Kaldi to K2 array.
I think the most likely kind of support is going to be things like importing data directories and like lang directories. So you can build the same system in K2. But I think having the components switching out is a little bit not really where I'm going, because the idea is to build a totally new type of system that has different components.
Right.
Hey, Dan, Mike Clark said something in the chat which sort of crystallizes my thinking that you should focus on the engineering of K2, and the rest of us here in this discussion, we're all interested in issues. So we'll chip in and make it happen.
Yeah,
Great
also,
new initiative.
We shouldn't just depend on Dan and JHU to do all the work. I think every one of us should allocate our time to contribute the whole things that we needed.
I agree.
I'd like to move to the next topic: trainability, teachability, documentation kind of stuff.
We had a lot of talk about that in the previous one of these sessions, which was focused on academia, because that was their big concern of theirs.
One thing I brought up during the email conversation is stability. Like I think some people share maybe the same thing, where when you try to train things with a lot of data, currently Kaldi sometimes is, you know, not super stable and doesn't have like super nice way to gracefully recover in between training. So I think that would be important, and it's kind of like linked to adaptation, like on the fly, kind of adapting AM or LM. But it sounds so far like if we're using PyTorch and stuff, all of that will.
Yeah, hopefully it won't be too much. But by the way, I did recently fix a bug that affected the stability of training. It's just a stupid bug where the weights go to 0, and then that constraint orthonormal thing fails, like after 500 iterations of training or something. Turns out it's because the matrix became exactly 0. So anyway, that's fixed.
Nice.
But the other
I think May, what you meant was more about training the staff and training people and making sure that, you know, we can have good educated workforce who actually knows how to use the tools and be efficient with that. And this was a common concern in the academic panel meeting we had for Kaldi. And I think it's an industry concern as well, because not everybody we hire knows Kaldi or K2 in advance. So one of the thoughts which we discussed a little bit earlier today, was to have a bunch of Jupyter notebooks, and maybe even we could invite people from academia and industry to contribute to that, and it could be a separate repository which kind of explores and explains different concepts of speech processing and algorithms and things like that.
You also need a good intro to FSAs and FSTs.
Yes.
Ones that they have are very hard to read and technical.
So Ishai, are you on the hook to contribute a little bit to those notebooks?
Yeah.
About this.
I heard that Piotr created some notebooks which you can contribute.
Yeah.
Okay.
Yeah. Actually, this is a good point to bring up with this panel. So I'll put on my academic hat. So in 2014 or so, I think it was 2014 or 2015, we got a grant from the National Science Foundation to upgrade and maintain Kaldi. Like, you know, these are from a program called, at that time it used to be called Community Research Infrastructure, and nowadays it's called Science Research Infrastructure. So basically these are things that the whole community shares, and NSF funds enhancing these things, maintaining these things. And our proposal actually had two parts. One was to do some of the DNN work and incorporate RNN-LMs and so on and so forth, which weren't there back in 2015. And the half of it was building training modules so that we could have people learn how to do these things. And NSF actually, the panel proposal was very highly reviewed. It got the top scores, but then the program cut our budget by half, saying NSF doesn't invest in the CRI program in training. This is not a CRI program prerogative. Go find money for it somewhere else. So that's why we are still a little bit behind on it. But I agree with a lot of things that people said, that we should create these notebooks and so on, and make it possible so that both students and new software engineers can quickly learn how to do things.
So about trainability for industry, I remember more than one of us bring up with training on large amount of data, including streaming from cloud.
Yeah, that's what I bring up actually. So the current Kaldi requires kind of the HPC framework, HPC infrastructure to train model. But now industry people are using more cloud environment, and because the inference usually happens on the cloud, and then a lot of data still remains in the cloud storage as well. So in the case, it's kind of annoying to copy from the cloud to HPC local disk like, or NFS disk like that. So probably if you can train the Kaldi model in the cloud friendly, like for example, we can kind of load data from the streaming way, like from the cloud storage directly. That will help, like kind of.
Yeah, so that is going to be a lot easier. Part of it is that we just have much better separation of things. So K2 is purely an FSA library, it doesn't deal with I/O. Lhotse will deal with I/O, but it'll have a kind of extensible mechanism so that you can add a new type of way of getting a file, for instance. So that you could easily integrate that with other Python modules that do your cloud I/O or whatever. And
that's great.
The actual parallelization of training would have to be a recipe level thing, because when you code that stuff in PyTorch or TensorFlow, you have to use, you know, an appropriate framework, but it has to know about the cloud stuff.
I remember that some of our the Kaldi recipes use the Slurm. I think it says something like a JH has been using. So is there any like other like a cloud like industry cloud structure that going to be like a AWS or the Google to be used for testing like a K2 for the parallelization of the training in the model cluster?
So let me jump in. Actually, there is a very nice project by Kirill who was supposed to be on the panel but is not. It's called, I think, Burmil or Burmila.
Yeah, well, I think that was kind of to do Kaldi on Google Compute Cloud. So he hasn't really been.
That goes to the question that someone was asking, maybe Wonkyum or someone, that like the Google Cloud is not possible to be used for training of the Kaldi models. And this thing can be used to train the models. I can, like, once we get to training on the K2, I believe it's possible to modify it to use the Google Cloud as well for this.
Yeah, cool. Right now, the main way we'll be dealing with that is simply by not wiring anything in too deeply that touches on I/O.
Yep.
But hopefully, eventually, we'll get to, you know, get nice examples on various platforms. And probably initially, we'll just use a single machine for training with like 4 GPUs or something.
Yeah, that's
It would be
something I
great
want
to have a link in the main page to those kind of like a sibling, like a Git pages, such as like someone is working on those like a running training on cloud. That link on the web page would be served. I think it's very helpful.
Yeah, I know that's something we should do. Unfortunately, we don't really have those examples ready yet, but you know, probably various people on this call will have like projects that they're doing or that they know of where people are training ASR models in various ways in parallel. Maybe if they can comment or something, maybe we can find a way to put them all together and look at what's out there and decide what to do about it. Eventually we'll have one place where we put all the recipes, but right now, because those don't really exist yet, we don't have a place. And also we'll have to decide how all that is structured. Like, I'm totally open to someone else, like ending up being, you know, the boss of the recipes. Like if some external project ends up doing a really good job of this, you know, then I'm all for it and I'm happy to help them. But, you know, I'm not going to nominate anyone because then if they don't do a good job, it's hard to claw that back.
Any other issue about trainability people want to bring up? Because sounds like a lot of that is covered already last week.
But what
will the script be provided in the shell form, or is going to what's the recipe is going to be?
Probably they're going to be Python scripts.
Okay,
but
that would be super.
Maybe they'll have shell components just to set them up.
Sometimes it's hard to get the integrating the monitoring stuff. If you're directly using the Kaldi script for the training in the industry, sometimes it's a failure in the middle. Using the shell is not like detected correctly. So those kind of like considering those things would be helpful.
Yeah, it'll be much more Python based. But we won't decide the structure of it for a while, I don't think. Probably initially we'll just have separate recipes and then decide what becomes a common pattern.
Sounds like you could have saved me a year of development there, Dan, if we did this last year.
All right, the next topic is pre-trained models. And whoever mentioned this first, want to go first? Mohammed or Theo?
Yeah, sure, we can talk about it. So I think this is borrowing a page from the Hugging Facebook. It was a really good thing to see in the NLP community where people are contributing their own pre-trained models. Basically, it's a model zoo. We see this in also TF Hub. And the nice thing about it, I think that they did a really great job with having the documentation, the model cards. You have this kind of standard view of like, here's how to reproduce my results. Here's how I got my data and how I ran it. And also like, here's how you can fine tune my model or build on top of what I built. The other thing is they added a lot of interesting widgets for inference, which I think it's another thing we have to talk about overall, like how can we get people to try the models in the cloud without even having to install Kaldi. I think it's doable these days, doing it on the web. So either you have some JavaScript or something that's allowing them to try, okay, in my use case, how is this gonna work? I see a lot of people here from the contact center business, like I am, and you can see the difference, of course, between like, you know, PSTN connections and AK audio versus what you expect from your laptop microphone. So a lot of these things would be interesting to see. Okay, I'm new to the speech community, or I have like a very specific application in mind. You go into the zoo and you're lost, right? So we need to guide them a little bit to how to use these pre-trained models.
Yeah. It'd be nice if, I don't know how to organize that. Maybe it'd be nice to have someone else thinking about that.
Because like the ecosystem
is not really my alley.
So Dan, the OpenSLR website is a good starting point. We'll have to develop that idea a little further.
Yeah. All right.
Yeah.
I think then you had a model zoo idea for Kaldi.
Yeah, and it never really. I think in the end, I didn't put enough effort into really keeping it up to date.
Yeah, I guess at one point we were pushing models to the website that Dan has, right? But later on, somehow, you know, we just didn't push a lot of models. But I still feel it's a very good idea if we can push some very nice pre-trained models to some website, for example, the Odo website, for two reasons. I think, you know, one is that when you look at, for example, ImageNet, right? It makes the task a lot easier, and it attracts a lot of people without a lot of backgrounds to work on that, right? And I think the idea of Model Zoo is kind of like similar. We are going to attract a lot of non-speech experts into this field. The other is from my own experience from my previous company. So eventually, you know, we did something like very simple for KWS for keyword spotting, but we made it super easy to use for non-experts. And we have like made it possible across different platforms and programming languages. And what we observed was that, you know, we did get a lot of non-experts using the tool. So what they have to do is they just clone the repository, they check out the model, and they deploy it to the device, and it can work. We actually shut down the business, you know, after I left Baidu, but we are still getting tons of emails asking for support for that. So I think it will be a very good idea if we can have like some kind of pre-trained models for Kaldi, and people can easily use that for non-experts.
Especially for languages other than English, it would be really nice to have pre-trained models to start from, because we have very little data in the target language, and then we just give up and use a cloud service instead.
Yeah.
So if we had a model to start with, it would be great help for the community.
Okay, I'll try to make sure that exists. I think part of
this is something.
Oh yeah, I'll try. It seems like an idea for a business plan, so that definitely there are costs for building.
I just don't want to put it behind a wall. But
yeah, I think it might. I think it might happen naturally, like, you know, from the community. If someone if people start committing some pre-trained models to Kaldi, and that will gradually happen, right? It's not like, you know, we have this nice grand plan and we just need to set up all those models, and it's not going to happen overnight. So if we can encourage people to, you know, contribute models back, it's gonna gradually happen, I guess.
Yeah.
In NLP, what's impressive about this pre-trained model is you can build a pre-trained model for all the languages. So it's one model. Don't laugh. We have a little bit experience on this multilingual pre-trained model now, and in NLP it does work. You just do a little. It does
work.
It does. We wish it works for speech too, but it's hard.
It's really difficult.
It is possible once you do some more tokens.
A comment on that, since you mentioned also NLP and I guess Hugging Face, standard BERT architecture, for example, or alternatives that are pre-trained. I was wondering, what about a better interface between ASR and natural language processing and understanding, especially now that there are some standards like BERT that use certain workpiece model, workpiece units, for example. Okay, what about trying therefore a better interface between them so that we, for example, manage to encode the uncertainty we have from the ASR, okay, and pass it naturally to the natural language understanding model, and maybe train or fine tune it.
I mean, of course, it should be possible to use K2 eventually for some of those NLP things, because it's about handling collections of sequences. But even without that, there should be easy ways to like extract things like n-best and confidences and then process them further with NLP. But of course, sometimes there's tricky details like having different normalization and stuff.
Yeah. Okay.
All right. Should we move on to the next one? What's the audience, competitors, and how do we market K2?
Yeah, I think the audience question is actually also very important. You know, looking at the previous focus was speech experts, people from academia, they were the current target. And honestly, I really like the idea of having it more adopted by others, the masses, like anybody who's interested, including just software engineers who have an app idea, right? And you can see this also expanding, not just in the experience access, but also in the application access, like using ASP.NET, you saw how it evolved from just an ASR toolkit into the TTS voice conversion and other applications. And a lot of folks who are in this call are actually all in the contact center space, and they understand how these applications interact with each other. It would be great to have a singular, framework that does more than just one thing. So if I, kind of try to dissect the segments, you will see the experts at academia. Go ahead.
Lhotse is the thing that's more general purpose because it stores speech databases in a way that's suitable for all kinds of applications.
Yeah, so you get
two for, let's say, the GTS, but you might include the Lhotse data sets.
No, but Mohammed, go ahead. You're trying to dissect the audience, if you will, and you're going to say something.
Yeah. So it was like speech experts in the beginning, and now you want to also cater for just machine learning scientists, deep learning scientists who want to break into the speech domain and without really strong, experience in that domain, making things easier for them. And then you have software engineers who are just interested in the black box. I really want the service to run. And then make it work from my application. So this is an AK audio. Maybe they need to know a little bit about input, output, but other than that, just want something to run and maybe fine tune if it's easier. I like the idea of Lhotse having this generic purpose goal, but you also have speech to text, and then you have text to speech mapping, and then you have speech to speech. So it has to also accommodate for these use cases. I think making it too generic might be a problem. I don't want everything to be, by the way, in K2 or Lhotse, because that's a wish list. It should be focused, but at the same time, we should have hooks and layers that allows us to build our own adapters. A lot of NLP, again, borrowing from that. NLP libraries were built on top of Hugging Face, and they just keep adding layers and layers until you have very high abstraction that allows you to do a lot of things without having to get into the details of how it's actually working from the inside.
If I may add something, I think that right now and in the past few years, speech, whether we like it or not, is becoming some kind of a commodity because we have all the offers from the big clients and customers are interested in the end application. So basically, we need to focus on the downstream task as well.
Yeah.
Mission, it's going to be better if we're going to focus on the downstream task and how to connect it with the NLU or other applications. It might be problematic in the future.
I agree with that, especially in contact center. You're absolutely right. The transcript itself is just a medium for the next downstream task, which is really more important. And people do not care as much about the verbatim in certain applications.
I think that's related to a question is that what's the positioning of K2, right? Is K2 positioned for very speech focused or could cover broader applications can be more generic to NLP as well? Or for example, if we consider Kaldi, Kaldi has established a very valuable brand. When people think of Kaldi, people think about highly accurate. People think about industrial friendly, right? It's like when we think of BMW, it's like a driving machine, right? When we think about Kaldi, there's already a very good image, right? Then, however, Kaldi has some limitations, as Dan already mentioned. There's regarding the neural network modeling, flexibility is limited, and also this growing complexity as it keeps developing, right? With the when I see the vision of K2, I saw that we are going to remove those limitations regarding we are going to.
It's definitely going to be much more generic. I'm not sure if I view this as like as a marketing task, because like when you're offering a product at zero cost, how does it really benefit you to market your product more? You see what I mean?
But where the Kaldi's good image regarding highly accurate and also industrial friendly be carried over to K2, right? Because that's what's people's expectation. We expect like any follower after Kaldi becoming like that. I think these two, if we can keep these two as
yeah, I definitely want it to be continue to be high accuracy, but yeah, the design is going to be very different.
I need to raise a point here. So there are other toolboxes, right, already that do speech recognition, ESPNet, Espresso, these speech brain projects. So in what Kaldi, we think of Kaldi as having this K2, which is an autograd class in the end, at the beginning of this, right? In what K2 is going to be different from or better to ESPNet or Espresso, or things that have been running for 1 or 2 years already, and people have been starting using, not just testing, but using it more seriously, right? I think we were talking about the audience, but this audience, I think, needs to be attracted. I agree with Tal about the brand Kaldi. I think that's a good brand for speech experts. I think beyond this field, nobody knows Kaldi, right? Let's be clear. I think it's a good point that we attract people from the AI community, but you know, they need to decide. People need to decide for something, and I wish they decide for this Kaldi 2 thing, but there need to be attractive points for them, right? And I don't see it clearly because ESPNet has been tested for 1-2 years, I don't know, and it's quite performing already, and people have the hang of it already. And now we come with Kaldi 2, which does super fancy things, but it's new. We don't know, but the performance is going to take 2 years to take off, and a lot of effort by the community. And
I don't really view K2 as a competitor to ESPNet because it's in a very different space. It's more a tool that's something that ESPNet might use. So like the actual competitor to ESPNet, if anything, would be the recipes that would create. But I was telling Shinji, if like he ends up, you know, taking on that and becoming that, I have no objection to that at all.
Yeah, I think that's a good point, right? To contribute to other projects, especially the K2, the backend, what you're building.
Yeah. So, yeah, it's like what I was saying before. Like, it's not the kind of thing that you can just declare, okay, the official front end is going to be ESPNet, because you can't control what somebody else wants to do with their life, right? Like, if Shinji doesn't feel like he wants to spend his time like maintaining a bunch of speech recipes, you know, that may be necessary to have a different mechanism. Yeah.
So since we're talking about ESPNet, should we mingle together on the topic of end-to-end speech recognition? Is this planned in K2?
Well, I mean, I don't like to use the word end-to-end because I don't feel like it's very well defined.
Yeah, I agree.
So definitely, like, one of the nice things about K2 is that it enlarges the space of what kind of decoders you can use, because there's a lot of these models where you'd like to be able to do recurrence on the word sequence or the phone sequence and have those as inputs to the neural net. So in K2, it becomes very easy to do that kind of thing because you can have a first pass decode that that gives you the candidate sequences or candidate lattice. And then you can take sequences from that and input to another neural net, and it's all jointly trained. So effectively you get the power of recurrent neural networks, but you don't really have the speed problems and the difficulty training them, or as much difficulty, because it's not really it's not recurrent in quite the same way, because even though it sees the input, those inputs were actually obtained by a previous pruning pass. So it can kind of process them all at once in parallel rather than having to recurse on each time step. Anyway, the point is there's a lot of things that people would conventionally call end-to-end that should be much easier to do in K2. I'm not going to use that terminology.
Well, we have flexibility of more separate acoustic model and language model. Because for commercial user, that is pretty handy. For industrial applications, to do something with language model is pretty powerful.
Yeah. Yeah, well, again, K2 aims to make it easier to, just separate those things. Like, if you want, you can have a neural language model, but you can also easily interpolate that with a normal language model. And if you want, you can jointly train those things.
Nikolai.
Yeah, well, the problem, end-to-end is a bad word, definitely. But like I wrote before, my concern is that next year Google will release, BERT-like model for speech, trained on 100 languages, on 1,000 TPUs, and it will work 50% more accurately. And, my concern is what we're going to do then and how we're going to develop our models. I think the concerns about C++ code will be invalid, but that's kind of happens. So we shouldn't worry too much about that. But things like, continuous adaptation and lifelong learning and learning from few examples is something we would like to contribute and work on. So anyone who is interested, let's keep in touch on that and think about how we can, create continuous learning algorithms, which can beat thousands of Google TPUs and thousands of NVIDIA
doing that
cards.
because they don't want to undermine their business. They provide a service for a fee, don't they, with their speech engine? Why would they give that out to a competitor for no money?
Well, they gave out GPT-3, right? And they gave out the BERT.
GPT-3 is like a cute trick. It's not like something that you can directly productize. Well, maybe you can for certain criminal schemes, but.
One of the things why image processing became very popular is I could, load some of these pre-trained models in Keras, do a few iterations with my own customized, much smaller set of data, and then I have something usable for the specific problem I'm planning. So, and it's good. Like K2 will be Python based, and probably there'll be Jupyter notebooks and all these examples floating around. So I think from a marketing perspective, it will actually become very popular because of those basic reasons. Nothing to do with all the technical reasons because of which you are making the transition, but just because, all those features will be there, which will make it easy for people to pick it up and run with it.
Xin, I saw you sign up end-to-end SR. Do you have any comment?
Yeah, so on some public datasets such as LibreSpeech, I feel the ESPNet or ESPNet2 performances has already been beating the TDNF models. So do we have some plans to catch up on that side?
I'm hoping to leapfrog it when we do the K2 stuff, because right now I'm not spending too much time on optimizing Kaldi models. Although I do expect that probably those ESPNet models, I think the kind of modeling strategies they tend to use can be a little bit like not robust for you know, for longer data or for online, so things like that.
Yeah, that's true. For online, it's probably not that applicable, but for some offline tasks such as meeting transcription, that could be useful.
Yeah,
when we finish K2.
Yeah, I actually agree with Mike because we've also like playing with ESP.NET recently, and the observation was like, you know, you can easily beat Kaldi on a specific task for like offline task without a lot of effort. You just take their standard recipe and run it through the data sets, and you can get probably, you know, nice improvement, like a 10% relatively. That's huge, right? So that's also like one of the concerns that I have. Dan mentioned that, you know, he's open to use K2, for example, as a component for another project. I think that's a good idea, but I think the value of Kaldi is really like, you know, Kaldi provides this whole solution for ASR, right? And people can take Kaldi with, you know, relatively cheap cost. They can get a very nice word error rate or even the best word error rate out of box from Kaldi, right? And if we are only using K2 as a component of another software or toolkit, I think the branding is gonna be the other software. It's not going to be K2, right? K2 is always going to be a component. I still feel it's a good idea if we can still work on the ASR systems. You know, we can, for example, have K2 and have other toolkits, but within this Kaldi organization, we can provide this very nice word error rate performance, you know, real-time factor, things like that. And people can use that, you know, for limited amount of cost. And I think that is going to be going to make Kaldi very successful.
We should probably have our own official example scripts, even if
exactly, yeah.
Not better than other toolkits.
Yeah. So if you look at ESP.NET, it's not like it's a fancy thing, right? It's just the scripts are fine-tuned and it's, you know, it's optimized for benchmarks, things like that. It's not like, you know, Kaldi is not able to achieve that. So we've been doing some experiments with Kaldi as well, and by putting all those components together, for example, you also have LM, we can achieve similar results, but it's just like, you know, for now, it's gonna take much more effort for Kaldi to achieve that. But a couple of years ago, you just take Kaldi, you know, out of box, and you can easily get the best word error rate.
I think back to the segments and the audiences, some researchers work directly with like Hugging Face and other libraries to get their papers as reference implementations on that toolkit, which is great. If we have a speech paper, it should be actually on that toolkit as a reference implementation.
Yeah.
May I make a comment in response to what Nikolai said earlier? I think, sorry, I didn't mean to interrupt, but I was thinking about it and I finally be able to figure out what I'm thinking. So Nikolai, I'm not too worried about, like, you know, Google coming out with like, you know, something trained on hundreds of languages and thousands of TPUs and tens of thousands of hours, which does BERT-like things to speech recognition. In fact, I would hope they do that because there are a lot of people for whom that's all they need. And they come to us and say, help us do this. And I'm like, guys, like, you know, we're not the right people to help you do that. Just go use the Google API. Like, you know, maybe pay for it if you want the premium one, you know. But there are a lot of applications for which that's not going to be good. So I'm not too worried about it. I just want to take the best of what they're doing, and they're good about publishing what they do, and create tools so that the rest of us for whom that is not the solution can go and build the solutions we need. That's how I look at it. It doesn't bother me. That's all I wanted to say.
We're in the long tail business.
Thank you, Professor Sanjeev.
Yeah. We have another topic to cover is what other related areas we wish to see within K2, but we also run out of time. Should we instead open up for audience Q&A?
What was the topic again, Mayu?
The last one, other speech areas. Like, should we have
5 minutes?
Oh, okay. Isha?
Okay. Yeah, so as I said, I think that, you know, the voice space is evolving, and we're starting to see more and more application, not just in the speech recognition space. So text to speech, voice conversions, all these, you know, speech profiling are getting a lot of attention and getting improvement. So when I'm thinking about K2, I'm thinking like the next steps that, because TTS is very new, quite new, not very new, I think that, you know, it might be good to incorporate these type of technologies and these type of techniques into K2, because it's going to open the platform for a much broader audience and in the voice space, which can be very interesting.
Let me think about whether there's any way to incorporate K2 into TTS. There might be actually.
Well, I'm thinking from the development schema, from the development schema, and making sure that K2 will be important for the broad audience, because
I kind of see Lhotse as the more natural connection to TTS, because like Lhotse has data preparation things that could also be used for that, but the TTS, like the algorithms are quite different than ASR algorithms, so I think that's why they haven't really been developed by the same people.
Right.
Let me add that we actually are actively working on a TTS dataset in Lhotse right now. So that should at least help.
Sorry, what about...
I think there are also, like, you know, single channel speech enhancement, multi-channel speech enhancement, deorization, speaker characteristics like emotion, gender, age, accent, things like that, you know. So I don't think all of these are specific to what specifically Dan has in mind or the algorithms that he's planning to implement. But regardless of that, you know, as we transition to a Python-oriented environment, I'm pretty sure different people could come up with recipes for each of these and just kind of contribute to a common repository, which might be K2 related or something like that.
Well, the way we're designing Lhotse is to support some of the, many of those tasks, like diarization is what we keep in mind as well.
I think it's more about feature extraction as well, right? A lot of people use Kaldi just to get to the, you know, feature representation that you want. So is this going to belong more to Lhotse?
Relatively trivial, like you can encapsulate that in a very simple Python. And Lhotse has that too.
Good.
Yvonne?
Mm-hmm.
I want to hear something from Yvonne.
Mm-hmm.
Ivan hasn't said much, so we're just hoping he'll say so. He always has ideas.
Is he still here?
Yeah, he's here. He's just
I'm here.
Go ahead, Ivan. No, we just haven't heard from you, so I thought you should, like, you know, I know you have good ideas. You wrote a lot of stuff in email.
Yeah, I wrote my concerns in email, so I think you covered all of these concerns in the discussion. So I just want to say thank you.
And Ian joined us late. He had to teach. So Ian, maybe you should just say hello to people. Ian has been contributing in email as well.
Hi, it's been good to see this change and this new push for Kaldi K2. My students have been working on this using Kaldi as part of projects at Carnegie Mellon. And then in 2014, we started a company initially with our own GPU-based decoder, but then seen in 2018 the collaboration between NVIDIA and you guys at Johns Hopkins. The new NVIDIA Kaldi decoder is pretty shocking at how fast it is on GPUs. So I think this is really cool, pushing forward into K2, leveraging PyTorch more, and with Junseok's taking the lead of our team at Twilio AI on the speech side, and we hope to now start contributing back into open source projects as well and getting this running at scale in industry applications. And it's really cool to see so many people that I know with Wongum here and Galgo as well. So it's a great team that we have on the call today.
Cool.
Sanjeev, so how do we run Q&A? Would you take over?
Yeah, so thank you. Thank you, Mayu.
Thank you, everybody.
By the way, a big hand to the panel and to Mayu for running it.
Thanks.
Hey, so Dan and everybody, there are a few questions, about 10 of them still sitting open in the Q&A. We could answer them live or type in answers. So should I just read them out aloud? So Anton asks, do you have plans for making Kaldi K2 more friendly for deployment on mobile platforms? And then there are some details. I think we addressed it. Do you want to say more?
Yeah. Well, hopefully just the fact that we can export to Onyx should make that easier, although we'll need a little bit of work importing K2 itself to mobile. And then of course, we'll have to have a pipeline for like turning your Python script into a C++. I know the pure PyTorch parts, we can do that. You're gonna have to figure out how to do that for the K2 elements of it.
Great.
I'm sure it's doable.
Yeah, anyone else on the panel?
The stream ain't gonna be ready. It might be a little while. We have to get the basic stuff working first, but we'll definitely keep it in mind.
Any like a build procedure that you have in mind to cross-compiling some of the engine part for the embedded as such for the C++ component now too?
I can't say that I've really figured that out yet. I don't know enough about that area.
Yeah, the next question was about, I think we answered it, was about, will the next Kaldi use some components from the previous
Well, we're using kind of the feature extractor, though we're making it in Python instead. Maybe eventually we'll use the decoder, but for now it's mostly a clean start, except for the experience.
So
the nested config files, we're getting rid of config.
Yeah, I was going to say, Dan, I think you answered it in the chat, but only to the panelists. So the question was, one of the major pain points with Kaldi is the nested config files. This is useful for model exploration, but becomes a pain. What is our plan for it? And Dan's answer was, Dan?
We're getting rid of most of the options and things like feature extraction. I mean, they'll still exist, but we won't be recommended to play with them.
Okay. The next
low latency decoder. Eventually.
Read the questions out because the audience can't see the questions, only we can.
They can't. Are you going to put efforts into having a low latency lattice decoder? Well, the low latency aspect might take a while because this GPU stuff is much better for fast batch things, but it's less easy to do like low latency things. It'll probably be possible with like some appropriate front end code, though we have to figure that out. For adaptation, so it should be easier to do adaptation.
Question, and whoever wants can answer them. The question is, anonymous attendee, adaptation, domain, accent, etc., both AM and LM is very important in industry. Will the next Kaldi have any plans to support this?
Well, it's pretty easy in things like PyTorch to take a model that's already been trained and then train a bit more. So the fact that everything will be based on PyTorch or TensorFlow should make that easier. Of course, it'll require some tuning to actually get it to work. Yeah.
There's a backward compatibility question. So let's say the K2 training code gets working and it's stable and we train a model. Can we use it with the current Kaldi decoder, the one that's optimized for GPUs and everything?
Well, I think it'll depend like what kind of model it is, because I'm hoping that we'll end up using these multi-pass models that have RNNLMs and like various decoding passes and stuff. And in that case, it won't really be possible to port it back, I'm afraid.
The next question is, where will statistical language models like ARPA formatted models and pronunciation lexicons, where will they fit within K2?
Well, because K2 is based on finite state automata, it fits in pretty naturally if you want to use those kinds of things, especially the statistical language models. About the pronouncing lexicons, I guess it's language dependent whether those are useful. You can use that, or you can use a graphemic lexicon. One advantage that K2 will have for things like CTC is it'll be possible to use a non-linear supervision for CTC. So if you have options in your lexicon, or maybe optional silence, it'll be possible to allow the training to take either option.
Yeah, by the way, I'll just say Mike Clark has been making some nice good comments in the chat and all. Thanks, Mike. Next question from Anand Joseph. This might be more relevant to the Lhotse, but this still involves K2. would be good to have something like the Montreal Forced Aligner or Gentle that makes use of pre-trained models to generate training data from audiobooks and other sources that have speech and transcription, but not reliable annotations.
Yeah, okay, well, that is something that we're looking at separately. So hopefully we'll get to that at some point, although it'll be at least a few months, I'm afraid, because we have to do the core stuff first.
Yeah, yeah. So we have a team working on this as well, yeah. Right.
Full decoding on GPU, Thomas Schaff is asking, is there any plans to do full decoding on GPU with lattice generation? Well, K2 decoding would naturally be on GPU, meaning both the neural net and the actual graph search is on GPU and with lattice generation. So yes.
Okay, I don't fully get the next question. Will algorithms for representation learning such as CPC?
Okay, I haven't heard of those, but maybe it's things like wave to vec and stuff.
Okay.
I
Sorry,
mean,
Kamendra, we can't answer it right away, but we'll dig into it.
yeah, well, I mean, I think like the framework doesn't disallow it, right? If you want to use those kinds of methods and if they turn out to be useful. But we'll have to see whether it's useful.
Okay.
Unsupervised, oh, this is the same thing.
The next question with the same question, will support unsupervised training such as VAB to letter.
Again, well, I think maybe the more relevant question is, will we support things like pre-trained models? Because I think the evidence that pre-trained models can help is probably more compelling than that things like WAF to letter can help. But I think the answer is basically yes.
Okay.
For both cases. At least it'll be easier. Any plan on supporting privacy compliance?
I think this is like more of homomorphic encryption, like deep polynomial networks.
Do those homomorphic things work for like more than one layer networks?
DNNs will work. You just need to approximate. So I would say not well.
Not well. Yeah, because mostly the models would have things like LSTMs in them. My feeling is that it's probably kind of impossible because like there's certain structural things going on when you generate a lattice and stuff. There's really no way that you can obfuscate that by like mixing up the labels, because you could work it out from the structure.
I think when you leave it to the community, like flexibility in design will allow them to like experiment with that.
It'll be easier than it was before, but it still might be fundamentally impossible. Sorry, guys.
Hey guys, believe it or not, we are right on the dot at 1:30 and we have answered all the Q&A questions in the box.
I always pride myself on being very punctual, so maybe we should finish now.
Back to you, Yenta. You started the proceedings, you get to finish them.
Thank you.
I hereby declare.
Thank you, Dan.
Thanks.
Bye.
Bye.